So the next step in this process is to set up some random extrusions on each of these. I want to go back into quads here. So we'll go to quadrilaterals. And we'll simply go here and into our next step. We're going to press tab and type the word poly and grab a poly extrude. We'll wire this straight in here. And we want to turn this into individual elements. So the distance here, we'll just move that up a little bit. And I'm looking for one other thing in here, which is our local control, I believe. Yes, so we can assign an attribute for each primitive that's going to control the scale. It's essentially going to multiply this value by whatever attribute exists on that primitive called z-scale. So let's go ahead and randomize this attribute here. So I'm putting down an attribute VOP. And I'm going to change this from points to primitives. And we'll call this setup extrusions. Dive inside. And we will start typing random, grab a random VOP here. We want our primitive number to drive the randomness value. We know we're going to get 0 and 1, so I'm going to press tab and start typing fit range. Wire the random straight into the value here. We will promote the min and the max, because we know 0 to 1 for our source is the range that's coming out of a random value here. So just middle click here and promote. Middle click and promote. And we will call this z-scale min. I'm going to call that min z-scale. Call this z-scale max. And then max z-scale. And for now, we'll just default both of these to 1. And then we will bind this. So I'm pressing tab and typing bind export. That will create the attribute for us. Just wire these together and call this z-scale. Now let's check if that's working for us. We'll take the minimum and drag that down. And now we see we've got each of these doing something different here. And then the maximum appears to be working. So we do get into one problem here, and let's show you how this works here. If I press tab and put a transform down and wire this in here, and then start scaling this down, you should be able to see that the shape doesn't remain consistent. So the scale of this remains consistent, but the shape looks totally different. We want some consistent results based on, so that as we're scaling objects and stuff, it doesn't feel like the appearance changes. So what we need to do is figure out a way to control the scale here based on our area of our primitive. So we can do this, and we'll do a test here right after a transform, and this will be deleted. We're just going to keep this here for testing. We simply put down a measure SOP. So if we press tab and type measure, and put this down here, we can change this to area. So this will actually measure the area of each primitive. And if I spreadsheet this and look at a primitive attribute, we have one called area. You can see we've got a unique value in here. So how do I know how much to multiply this by with that value here? If we have, or we can compute the area here, we know that if this is a square here, the unit here, this times this will equal the area. Same with this times this equals the area of that. So to find some kind of consistency, we need to reverse that, which means we should find the square root of the area for a perfect, we're talking about a perfect square here, but it should work overall here. So we simply will go in here. And we will bind area coming in. And we will press tab and start typing square root, SQ, square root. Grab the square root of our area and we will multiply our value. So multiplying right here, putting that right in. And now let's try this transform again and see how that works for us. So it appears to be relatively consistent, hopefully identical or very close to identical, no matter what we do with the scale there. We'll keep this here for now, and then we'll set up some inset as well. But for now, let's just save our node and the file and continue. So we're going to go ahead and set up a random inset as well. So going back in here, let's take a look at poly extrude. And you can see that we have some inset value, but we want to randomize this. So how can we do that? Well, we have an attribute here called inset scale. So we'll essentially just do the same thing. We'll activate that. We'll go into our extrusions here. We'll simply start by giving a different random seed value. So I'm just going to press tab and start typing the word add. We will add a constant. So that's going to add a constant value into our point number. And I'm just going to basically finger mash the keyboard, give us some big number here. We'll put that again through a fit. And then, of course, we need a random. So a second random. Let me move that up, a little tough to see. There we go, random. Sorry, I'm making some space here. Let's get organized. Kind of line stuff up. Okay, so we'll take that random, bring it into here, and just as we did before, we'll promote these two. We'll call this min inset scale. And then same with max here. Let's just default that minimum there to 1. And again, we're going to need to multiply that. So pressing tab and multiply. That will have to be multiplied by the square root of the size of our primitive. I'm going to press tab and bind, and we will grab a bind export. And now that was called inset scale. Let's check how that's working out. So that appears to be working out correctly. And we're just going to label this so we know what it's doing here. And then again, we're going to save our progress. So right-clicking, choosing Save Node Type, saving our file, and then we'll pick right back up.